Hello everyone, welcome back to the channel. Today we are going to learn design and simulation of SEPIC converter in MATLAB Simulink. Before going to the simulation, let's first understand what is a SEPIC converter. A SEPI stands for single-ended primary inductor converter. It is a type of DC-DC converter used to step up or step down the voltage from DC source such as a PV, battery or any variable DC supply. Why is it called SEPIC? The name comes from three parts. First one is single-ended, only one switch is reference to the ground. Then primary inductor L1 is directly connected to the source and store the energy. When switch is closed, the inductor is directly to the grounded. Then converter, it converts DC into DC. So together it is called a single-ended primary inductor converter, that is meant by SEPIC. So a circuit is called single-ended when the switching device MOSFET is connected to the ground on one side instead of using a bridge or push-pull arrangement. In a SEPIC, MOSFET is referring to the ground. The inductor L1 is also reference to the ground. When switch is on, then there is only one active switch. So the converter has a single-ended switching structure. The first inductor L1 is directly connected to the input Vs. So therefore the L1 acts as like as a primary energy storage element during the operation. So what will happen? L1 stores the energy when the switch is on. So therefore L1 transfer the energy to the C1 when the switch is off. The output is non-inverting and both inductors, that is by L1 and L2, work together to regulate the output. So the single-ended is meant by only one switch is reference to the ground. Then primary inductor L1 is directly connected to the input source. The converter input DC into desired output DC. So let's move to SEPIC operating principle. It will be operated on two modes, when the switch is on and when the switch is off. So let me discuss about when the switch is on. When the switch is on, the inductor L1 charges from the input. So therefore inductor L1 current is linearly increasing. So in the inductor L2 charges from the coupling capacitor C1. So therefore C1 supply energy to the L2. So what will happen? Inductor current L2 also what? Linearly increasing. So this diode D becomes reverse bias. So therefore this output load isolates from the input. So the load is powered by only the capacitance C2. So the coupling capacitor C1 discharge. So C1 transfer the energy to the where? Inductor L2. So this is the operating principle during the what? When switch is on condition. Coming to the second condition, when the switch is turned off, L1 release the energy to the capacitance C1. So therefore L1 current flows into C1. Now C1 becomes what? Recharge. So L2 release the energy into the load through the diode. So now the diode D forward bias C1 and also both inductors L1 and L2 contribute energy to the output to C2. So the output C2 store and deliver the power to smooth the output voltage. So this is the operating principle of our SEPIC converter. So today I chose a circuit from a journal and also I referred the equation from the same journal. So here the duty cycle you can see that Vout divided by Vin plus Vout. Then inductor L1 value is calculated, similarly L2, C1, C2. Now let's move into the MATLAB Simulink model of the SEPIC converter. So we will create the input source, then two inductors L1, L2, then series capacitor C1, then MOSFET switch and PWM control, then diode, then output capacitor C2 and also load resistance R2. Then after that pulse generated, voltage measurement and scopes. First we will choose the input source. So I will choose a constant voltage source. Then after that I will choose inductance RLC branch. Then I named this one is I choose inductance, named this one is L1. Then after that I copy and place. So this one becomes L2, name change to L2. Then after that place capacitance value, connect the capacitance in series with the L1. So C1, then after that C2 parallel to the resistive load. Then load, we connected load, this one change into R, we use R. Then MOSFET switch, and another one is diode. So neglect the snub resistance values, apply OK. Then connect all the elements as I shown in above the circuit diagram. The input source is connected to the inductors, then capacitance and diode. Then connect this one, then connect load parallel with the capacitance, and connect it here. So let's complete the circuit. PWM generator for DC to DC, choose and connect it here. Then I have to take step input to connect the voltage source. Then after that we will take constant to give the duty cycle to the PWM generator, connect it here. And then I will take voltage measurement and current measurement block, connect voltage measurement parallel to the load. Then connect another voltage measurement block to measure the input voltage here. Then current measurement, connect in series with load. So let's measure this, all the outputs through the scope. First I will connect the input voltage, then output voltage, then current through the resistance R. Current through the resistance R. Okay. So let us take here the initial amplitude I will consider as a, here I change it to DC. Apply. Okay. Let me take a step input to 0 here, then input VIN, then apply. Here also I choose the final values V in input voltage. So now we are going to design a SEPIC converter in buck mode. The output voltage is lower than the input voltage. Okay. So we change here the C1 capacitance value, change the capacitance value, C2 apply. Let's do the coding. Based on the equation we are going to generate the Simulink coding. So first one is I am going to choose that the power of my SEPIC converter is 500 watts. The input voltage I choose here 48, then and also I choose a 20 kilohertz frequency. The output voltage is 32, so therefore the input voltage is 48. The output voltage is lower than the input voltage. It operates in the buck mode. Then the duty cycle as I shown in the formula, I chose Vout divided by V in plus Vout. Then I have calculated the I in current, then I out max, then calculated the value of resistance value. Then after that I found out the value of L1 with respect to this formula. You can see that you can refer this formula. L1 is equal to V into D divided by del IL1. And also Fs, the switching frequency, and also input to the, we chose the input voltage is equal to here 48. Then calculate the value based on this formula. Then after that similarly L2 value is calculated based on the Vout. So that is meant by we refer the Vout value is equal to 32. So let me simulate this coding. So you can see here the minimum value of capacitance we have designed C1, C2, and also the duty cycle is equal to 0.4. The switching frequency is what, 20 kilohertz. Then L1, L2, then R is equal to 2.048 ohms. Okay, so we will check that how it is operated. We designed here in a open loop condition. Okay, so let's give the D duty cycle to the our PWM pulses. then here set the frequency value. I choose 20 kilohertz fs. Now run the simulation. So as you can see that, so the input voltage we applied here, it is a 48 voltage, and also the output we are getting nearly it is equal to 32 voltage. Okay, I hope you learn. You can see that. So nearly we reaching the 30 voltage because it is a open loop operation. You can see here I use a display to measure the value from the output side. You can see here. So let's say simulate once again. You can see the nearly it is equal to 30 voltage. We designed the SEPIC converter for 32. Nearly we getting what 38. So this is a open loop operation of our SEPIC converter. So far we have seen the SEPIC converter operated in buck mode. So now let me see how it is operated in boost mode. The same formula, just I am going to change then the output value, then 48 to 60 volt. The same power I choose here, frequency also same, just I changed the output value Vout. Then similar this, now run the simulation. Now the values are updated. Now once again we move to MATLAB Simulink, then we will simulate. So here all the values are updated. So you can see the display. It is nearly we are getting it is equal to 60 volt. So this SEPIC converter operated in a open loop condition. So therefore we are getting a more or less nearly equal to 60 voltage. So you can see here. So this is the open loop operation of SEPIC converter. The input voltage is 48, the output voltage is 62. So that's what I earlier told that it will be greater than the input, that is when we operate in boost mode, and also less than input operate in a buck mode. The SEPIC converter is very popular in PV panel MPPT system and also battery chargings and also LED driver circuits and then automotive and industrial DC supplies. So this is the open loop operation of our SEPIC converter. So I hope you learned something new today. Don't forget to like, share and subscribe. More MPPT and power lines projects are coming soon. Thanks for watching.